All right, we're back again for another Ohio State test review by standard. Today we're talking about 8.EE.8. This has to do with systems of equations, which is always it can be controversial, mainly because either it's not awful or it can get messy. Okay, so let's talk about how we're going to do this. Number one, the system of equations is shown. Y equals 5x plus 2, y equals 6x plus 1. So, if you're presented a system where it's just y equals, like this, all you're going to do is you're going to set the equations equal to each other. Okay? And when we talked about it in class, the way I said it was that imagine instead of having variables here, you had two equations where it said that 7 is equal to 5 plus 2, and 7 is equal to 6 plus 1. And all we're doing is we're saying that 5 plus 2 is equal to 6 plus 1, because we can surmise that based off of our given information. That's all we're doing here. If we know that this equals 7 and this equals 7, then these two equal each other. If we know that this equals y and this equals y, then these two equal each other. So we're going to solve for x. Because our goal with solving system of equations is to get it so that you only have one variable. That way you can solve for that variable. We're going to follow our same steps of equation solving as we normally do. Remember your mnemonic device, don't call me after midnight, which is distribute, combine like terms, move all variables to one side of the equation, undo your addition and subtraction on the same side of the as the variable, and undo your multiplication and division on the same side of the variable. And I realize that got cut off, but yeah. So, do we have any distribution? No, we don't see any parentheses. Do we have any like terms? Well, we draw the fence through the equal sign. Do we have any like terms on the same side of the fence? Remember, a like term is anything that has the same variable and the same exponent. So because 5x has an x and 2 does not have x, they are not like terms. So now we go to move all variables to the same side of the equal sign. When I move all variables, I like to move the smaller variable because I like to try to keep things positive. So I'm going to move this 5x. You move the 5x by doing the opposite. So instead of positive 5x, it's negative 5x. That'll cancel this out as 5x minus 5x equals 0. Leave you with 2 equals x plus 1. Then we undo our addition and subtraction on the same side of the variable. So again, we got to get rid of the 1. We do the opposite. Subtract 1. 2 minus 1 is 1. 1 minus 1 is 0, so it cancels. You get 1 equals x. So we know that 1 equals x. But we still need to find y. The way you find y is you go back into your original equation. Okay? You pick whichever equation you want, whichever looks easier. I'm going to pick the bottom equation. Y equals 6x plus 1. And you're going to take out the x, and you're going to put in what you found for x. And then you're just going to solve for y. So we go right to our calculator. 6 parentheses 1, close parentheses, plus 1 equals 7. So y equals 7. And you're done. And that actually kind of hilariously worked out with my example that we did there. That wasn't planned. But, yeah. All right, next question. Lines A and B form a system of linear equations. Each line contains 2 of the points shown. Move a pair of coordinates to each box, to each blank box, to complete the statements so that the system of equations has one solution. Okay, so here's what you need to do. Okay? In order for a system of equations to have one solution only, the only rule that needs to follow is that your slopes cannot match. Because if your slopes are the same, the lines will never make any progress towards or away from each other. So meaning if you have a line like this and a line like this, and their slopes are exactly the same, they're going to stay parallel forever, which means they will never cross. Or if you have a line like this, and then another line that's perfectly laid over it, and that means their slopes are the same, and they are always touching. So all you're trying to do is create a situation where your slopes are different. So you pick two of the points, right? So let's do these 2 points. Let's say I want line A to be these 2 points. So remember how we find slope. Slope is m equals y2 minus y1 over x2 minus x1. Your change in y over your change in x. So when we did this originally, we labeled these x1, y1, x2, y2. And we plug it in. 5 minus 6 over negative 2 minus negative 2. And that would end up giving you, let's see, 5 minus 6 equals negative 1. And negative 2, negative 2 minus negative 2 would give you 0, which this is already not a good start, but we can work with it. So our remaining 2 points have to have a different slope. Okay? So again, x1, y1, x2, y2. So now we do this math again. 5 minus 6 over 5 minus 5 equals negative 1 over 0. Uh-oh. They're the same slope. So this combination doesn't work. Okay, so we're going to erase. Well, I shouldn't have erased the slope formula, but here we are. I'll rewrite it. So now you can see that we already have answers filled in. So let's see what the answers that are filled in looks like. This would be x1, y1. This would be x2, y2. So that would be y2 is 5 minus your y1 is 6 over 5 minus negative 2. 5 minus 6 we know is negative 1. 5 minus parentheses negative 2. Close. 5 minus parentheses negative 2. Close parentheses is equal to 7. Now let's check our second point. x1, y1, x2, y2. So this would be 6 minus 5 over 5 minus negative 2. 6 minus 5 is 1. We just determined that 5 minus negative 2 is 7. So this is negative 1/7. This is positive 1/7. Our slopes do not match, so therefore this works. You got to find a situation where your slopes do not match. All right. The graph of the system of equations is shown. What is the solution to this system of equations? Enter the x-coordinate in the first box, the y-coordinate in the second box. So I believe this ends up getting cut off. So on your test, it would probably look something like this, where you have parentheses, a box, a comma, another box, and then close the parenthesis. So remember, the solution to a system of equations on a graph is just where your two lines cross. That's it. So right here. All you gotta do is figure out what this point is. Well, to figure that out, you start from the origin. You went right 2, so that's positive 2. And you went down 1, 2, 3, 4. So that's negative 4 because you went down. Done. All right. A system of equations is shown. Y equals 2x minus 7. Y equals negative x plus 5. So this is the same situation where this is y equals something. This is y equals something. They're both y equals something, so you're just going to set them equal to each other. And we're going to solve for x. So we go to our don't call me after midnight rules. Do we have any distribution? No. Do we have any like terms on the same side of the fence? No. So next we go to move all variables. So I'm going to move my smaller variable, which would be negative x. I move it by doing the opposite. So I add x. 2x plus x is 3x minus 7. This cancels out. 5. Okay? Now I have to undo my addition and subtraction on the same side as the variable. So I got to get rid of this negative 7. I'm going to do that by adding 7 to both sides. That's going to leave us with 3x equals 12. Finally, I get rid of my multiplication and division by dividing. 3x divided by 3 leaves you with just x. 12 divided by 3 is 4. So that's our x coordinate. Now, we just go back to one of our original equations. This one I'm going to work with the top. Take out x, replace it with what you just found for x. Type this into your calculator exactly as you have it. And it gives you y equals 1. So you put in 1. And you call it a day. All right. So, oh my goodness, we still have a lot to go for this one. We still have quite a few questions. All right. A system of equations is shown. 2x minus y equals 15. Y equals 9. This is a lot simpler than the other equations because they already told you what y is. There's no solving for y. It's already done. So you're just going to skip to the step where you go to the other equation. 2x minus y equals 15. You're going to take out the y and you're going to put in 9. Because they tell you that y equals 9 right here. Equals 15. 2x minus 9 equals 15. Now we solve for x. No distribution. No combining of like terms on the same side of the fence. All of our variables are already on the same side. So we undo our addition and subtraction on the same side of the variable. So we get rid of this negative 9. How? By adding 9. That leaves us with 2x equals 24. Then we get rid of our multiplication and division on the same side. You do that by dividing by 2. And you get x equals 12. And now, normally you would find this as a coordinate pair, like how we did up here, or how we did up here. But in this situation, the question is only asking you, what is the value of x? The value of x is 12. So you just put in 12. Just 12. Don't try to put in a coordinate pair. Don't try to put in 9. Tells you what is the value of x. The value of x is 12. Okay? Okay. Karishma and Joshua collect shells on the beach. The given equations model the number of shells K that Karishma has and the number of shells J that Joshua has. How many shells does Joshua have? Okay. So, here's how this problem goes. We no longer have the ease of just it being y equals y equals. However, we do have a situation where we have solved for j. We know what j equals. So in previous problems, when you found x, what you would do, or even when we had y, we would go to the other equation. We would take out what y, we would take out y and put in what we know y is. That's called substitution. We're going to do the same thing here. We know what j is. Is it a simple number like y was in the last problem? No. But we know what j is. J is equal to k minus 30. So we're going to take this and we're going to substitute it in for j in the original equation. So k plus k minus 30 equals 54. We rewrite without our parentheses, and now we go into equation solving. Distribution? None. Combine like terms on the same side of the fence. We have k plus k. K plus k is 2k minus 30 equals 54. All of our variables are already on the same side of the fence. So we go to undo addition and subtraction on the same side of the variable. So we got to get rid of this negative 30. We get rid of the negative 30 by doing the opposite and adding 30. That leaves us with 2k equals 54 plus 30 is 84. Undo our multiplication by dividing by 2. You get k equals 42. Now, k represents how many shells Karishma has. But what's asking us is how many shells does Joshua have? Okay. So what we're going to do is we're going to go back to our second equation. J equals k minus 30. J equals k minus 30. We found k to be 42. So I'm going to take out k and put in 42. And then 42 minus 30 is just 12. So Joshua has 12 shells. And that's it. The graph of a system of two linear equations is shown. Which point represents the solution to the system? There's no real long explanation for this one. The solution to a system of equations is where the two lines cross. Where do our two lines cross? At R. So it's R. That's it. Short, sweet, to the point. If they give you this question on your test, count yourself lucky. Because it's just pick the point where they cross. All right. A system of equations is shown. X plus y equals 7. 2x minus y equals negative 1. Okay. So, the first step to solving a system of equations is that you're looking for something. You're looking for either an x equals or y equals, so that you can do this by substitution. The unfortunate part to this is that we don't have that situation. We don't have x equals something. We don't have y equals something. So we're going to have to create that situation. The equation I find easier to create that situation is the top one. X plus y equals 7. You could either move the x over by subtracting x, or you could move the y over by subtracting y. Okay? I am going to solve for x. So I'm going to move the y over. So we subtract y from both sides. I didn't draw the fence, I apologize. So that leaves us with x equals 7 minus y. Now we have an x equals. So we can take this and we can plug it in for this x. So let's do that. 2 times 7 minus y equals negative 1. We took out the x. We put in what we found x to be. Now we go to standard equation solving. Step 1, distribution. We have parentheses, so we have to distribute. Remember, distribution is always, always, always multiplication. 2 times 7 is 14. 2 times negative y is negative 2y. Minus y equals negative 1. Then we look to combine like terms. Remember, you're looking for any like terms that are on the same side of the fence, which we have here, negative 2y minus y. To combine them, we just combine their coefficients. Negative 2. Come on. Negative 2 minus 1. Because if you don't see a coefficient, you assume it to be 1. That gives you negative 3. So we now have negative 3y equals negative 1. Undo our addition and subtraction on the same side of the equal sign, or on the same side of the variable. So we're going to get rid of the 14 by subtracting 14. That leaves us with negative 3y equals negative 15. Get rid of your multiplication and division on the same side of the variable. This negative 3 is being multiplied by y, so to get rid of it, we do the opposite, which is dividing. Y equals negative 15 divided by negative 3 is positive 5. So we know that y equals 5. So now we have to go back to one of our original equations. I'm going to choose the top one because the top one is an easy equation. We're going to take out y and put in 5. X plus 5 equals 7. You can probably figure this out without having to do the equation solving process, but just to stay up to date on solving equations, you solve this by subtracting 5 from both sides. You get x equals 2. So your x is 2. So that is systems of equations. And I said systems of equations do not always come easy. There are some people who can get it like that, and there are some people who will struggle with it, and that's fine. Okay, it is a complicated process. So just do your best. And remember, if they give you a graph, the solution to the system is just where the lines cross. But that's going to do it for this video. Oh boy, this was a long one. So I'll be back for another standard. Until then, thanks for watching, and good luck on your state test.